So what do we have today?
So this will be a series of videos intended to be brief on single subjects, for which I would like to hear a physicist explain how I'm saying or going to say something incorrect or wrong in the video about...
And why would you want that? Because when they do it, you ignore it and deny it.
The state of physics. So in this case, we're going to talk about springs. We're going to use a tennis ball as an example, so we'll start with that. I couldn't do...
Right, so we're talking about springs and you're using a tennis ball as an example. Yeah, okay. If you'd wanted to show a spring, you're quite welcome to use my footage.
Not a very good video for slow motion, but anyway, you get the drift. I hope you got the drift. The ball wobbles, so it hits the ground.
Yeah, but it's a tennis ball. It's made out of rubber and felt. It's spherical. It's got a lot more surface area, a lot more friction. It's not a spring. It's made out of an entirely different material. It will also be rotating when it hits a little bit, so it's not going to give back anywhere near all the amount of its energy. They're quite inefficient. They're a plaything. They're not designed to project something linearly.
It's not moving at all right? It's nice and steady, and then when it bounces back, it's doing this. All right, and that's a problem because that motion is what really steals an awful lot of the ball's capacity.
Yes, it did, because they're not very efficient in giving back their energy. Because it's not a spring, it's a tennis ball.
To release the stored energy. So you put the energy in, it compresses, it creates pressure, does all kinds of good.
Also, does it follow Hooke's law? Like a spring? Maybe it does, maybe it doesn't. You'd have to research it, wouldn't you?
Things, and then it fails dismally to actually leave with the same velocity it went in with. And
yes, because tennis balls are pretty inefficient. They make a lot of noise as well, which is obviously energy loss.
Big problem is the fact that that ball is wobbling, which is the same, you could argue, as angular rotation in wheels on cars.
How is a tennis ball resonating after a bounce anything like angular rotation?
That it's energy that won't be linear motion. So the heavier the wheels, the smaller their turning radius, the faster the axle's spinning.
Ooh, learnt something new there, have you? Add that to your repertoire, just sneak that one in like you always knew that. Yeah, the other day you were telling a PhD physicist that couldn't be true. But anyway, there you go.
That's all energy that you won't see as linear motion because it's essentially stored energy. So in any experiment, the argument is that you're going to use springs in. And if you're going to have some assumption that you're getting most or all of your energy back.
But it's not an assumption because we can test these things. I will link to a physical experiment where I showed the efficiency of a spring. I didn't just make up some number, I tested it.
You're wrong, and if you have some assumption that it doesn't matter what mass you put on it, you'll lose the same proportional amount of energy, you're wrong. Okay, so...
And again, you're saying it's wrong. Have you tested it? Have you got any evidence to show this?
It's a pretty important subject. I haven't seen any physicist that talked about it. So, it's sort of glaring in terms of the fact that it really should be talked about by physicists.
Not if it's not a problem, they won't.
They're going to do experiments where they're going to move objects with springs. And that includes a lot of experiments where they use a spring to create a super elastic experiment.
They use them because they're very efficient. You know, a good quality steel spring it can be anywhere from 90 to like 95% efficient. In the link I provided, I got just under 93, so middle of the road there. So that's about right. That's how efficient they are. They're designed that way. Like I say, a tennis ball is not a spring.
The problem is simply that when you move something with a spring, it has to have contact with the spring. So in
Well, fucking duh. Nothing like stating the bleeding obvious there, is there?
a sense, Hooke's law only applies in terms of oscillations if the spring is actually attached to the mass. So it always has contact. But as soon as you have a spring mass system where contact is lost, then there's...
Well, if you're launching something, at some point contact is going to be lost, isn't it? Usually when the spring extends back to its original length.
This problem where, let's say this is a light mass, should make it smaller. Well, it doesn't matter. You get it. We're just there. This one's more dense. There.
Bit like
Okay.
you.
When you're shooting a light mass, let's say the mass was going to go 50 miles an hour. The spring,
You know what spring you're using there?
as it's expanding, is still going 49 when the mass leaves at 50. So when the mass is leaving, the spring still has a lot of velocity that it's not using because there's no mass to push. So this is the...
But again, this is just shit that you say. You haven't tested it, have you?
essentially what the tennis ball is doing when it flies off and it's lost contact with the surface and now oscillates. Spring is going to do the same thing. And the catch is that when you're pushing a heavy mass, say you're only going 10 miles an hour, that's how fast the spring's going. It's only going 10. So there's going to be a lot less energy stuck in.
But in each case, the spring stored an amount of energy. It extended back through that distance with that force into that mass, so it delivered the same amount of energy to each mass, regardless of how fast it was going.
The spring, because the velocity of the spring is much lower, it'll be doing a lot less oscillating, and it would have put...
And again, why will it be doing a lot less oscillating? Have you tested it? Have you shown this to be true?
much more energy into the object. So the simple truth is springs have a huge bias in the sense that they'll always put more energy, okay, in heavy things.
Right, so they've got a huge bias. What's that? That's a pretty ambiguous statement there. So no numbers, no evidence, just you say so, so therefore it's so. Doesn't work like that, does it?
And less energy into light things. So the simple argument is that physics does lots of spring experiments, and none of the...
Yeah, they use them because they're very useful and very efficient.
Physicists talk about the fact that springs have a substantial bias against light things, where...
Again, a substantial bias, what's that? Give us some numbers, give us some evidence, give us some experiments to show what you're saying. Again, you're just making shit up.
They're going to give disproportional amounts of energy to the lighter the thing you put in front of one. So the heavier the object...
But when these experiments are done, that doesn't happen. That's not what's observed. So again, you're just talking crap.
But the more energy you'll get out of the spring. So the same spring compression will, for example, create, let's say, for a heavy object, it would be 100 momentums. For a very light object, it might be 10. So they're...
Again, you have no fucking clue what you're talking about here, do you?
really bad for doing clinical experiments to calculate or find the how much energy you transferred, or to make
the energy is in the spring, it's stored in the spring. Doesn't matter what mass you put in front of it, you get the same amount of energy.
Comparisons between two different things, like an 8-pound bowling ball and a 16-pound bowling ball, or some other kind of experiment. You want to test them for how much energy they can produce, where you can't launch them with spring.
But we know how much energy it's going to produce because that's the amount of energy stored in the spring. If you compress it to the same amount, that's all you've got. You can't get any more or less. There's no free energy.
Because the same energy won't get into both balls. The heavier one will get more of the momentum than the light one will. And so if you have the assumption...
And again, you're making this assumption that there's momentum stored in springs. Again, demonstrate it. Show it to be true.
And that the spring is going to give the same amount of energy, the assumption is wrong. And it will...
But the evidence says otherwise. It's not an assumption. You're making an assumption and you're showing no evidence to support it.
And it will destroy the credibility of the experiment. So the simple argument is first, physicists never talk about it. If they have talked about it, they don't pay any attention to it, because every single time they do an experiment with a spring, they make the assumption that the same energies...
No, again, they don't make the assumption. You can test and measure these things. You're making an assumption. You're just projecting. That's all. Because you've got fucking nothing. You know nothing.
Going into the object when it's not. All right. So my challenge to physicists is explain where this isn't a problem for doing spring experiment.
It isn't a problem. You want it to be a problem to fit your bullshit fucking theory.
Or explain how it isn't a fact. So either explain how
it isn't a fact.
It's not a problem, or explain how it's not a fact.
It's not a problem because, like I say, you can do the experiments and it shows it's not a big issue. Again, you know, yes, they're not going to transfer 100%. That is in an idealised case. You know, a good quality spring, you're looking between, say, 90 to 95% efficient when launching with them. So yes, there's going to be some loss. There's friction. There's air resistance. You know, it's not ideal. You're not going to get 100%. But you're claiming, well, what are you claiming? Substantial loss. What's that? Give us a number. Pin yourself down so we can test it and prove you wrong. But you don't do that, do you? You just come out with vague, ambiguous statements of, oh, well, they're just not very good. Well, we could all say that.
Thank you. And that'll be it for this video.
So yeah, basically just a load of crap. The thing is, if you're so bothered about launching with springs, we could drop masses onto springs, because by your own admission, springs collect energy really well. And yes, they probably are a little bit more efficient. You're probably looking more to, say, 95 to 98% efficient when doing that. So wouldn't it be interesting if somebody did that and maybe showed it to you? You just can't fucking handle evidence, can you?